Welcome to data analysis in Excel. Excel is one of the most used and popular tools for data analysis as well as business intelligence. It is widely used in every industry by almost every team of analysts. And as Excel is broadly available and is probably familiar to you already, it is a great starting point for our learning journey with data. This course will cover how we can reshape, transform, analyze, and visualize data to become highly efficient in working with any data in Excel. We will focus on analyzing and transforming data with functionality from the ribbon in Excel. We'll review common Excel functions that can help us with our analysis and transformation of data. We'll look at how we can reshape and structure our data, preparing for and conducting a more robust analysis with Excel tables and pivot tables. And we'll explore some features of modern Excel, supercharged data analysis with linked data types, dynamic arrays, and ideas in Excel. Data analysis in Excel is part of CFI's Business Intelligence and Data Analyst Certification Program. This course provides the necessary skills needed for our later business intelligence and Excel-based courses. Let's get started.
In this chapter, we will look at some common ways to analyze data in Excel. We will use a combination of features, from buttons on the ribbon to popular Excel functions. We will go through a few different examples to see how we can do a few different things. We'll look at how we can sort and filter our data, how to apply conditional formatting to our data to help communicate insights more clearly. We'll use some popular Excel functions for conditional logic and mathematical formulas, and we'll also see how to create our very own functions, specifically for our analysis. By the end of this chapter, we will have a better understanding of the suite of analysis tools available to us in Excel and how each of them can help us with our analysis. Let's get started. Let's start to analyze our data in Excel. Here is the example dataset that we'll be working with for the next few lessons. We have columns that specify the category, product, and store of a particular item. We have additional numeric columns that indicate the volume, price, and cost of those items as well. A common part of exploratory data analysis is sorting and filtering our data. This is also a basic way to provide some initial insights, as we can quickly see products or stores in order. Let's start by sorting the store column here. I can click on the column and then navigate to the Sort and Filter button here. This is located in the Editing section of the Home tab on the ribbon. From the drop-down, I can select Sort A to Z, or alphabetically. And we can see now all of the data in these columns is sorted in ascending order by the value of the store column. For the other data to change with the store column, as we've seen happen here, it has to be a continuous range of data. If there is a space between, say, the cost column and the rest of the data, I'll insert one here, and then we sort the store column, this time Z to A, we see that this cost column does not update. All of this data sorts properly, but the cost column does not. And now, the incorrect cost values are associated with the rows in the rest of the data. I'm going to undo those last two steps. We can sort numeric columns as well as text columns. I can sort this product column in descending order, from largest to smallest. When I do this, we can see that we've lost the sort order from our previous action in the store column here. If we want to maintain this sort order, or have multiple levels of sorting, we can use a custom sort. To do this, I can select the custom sort option from the drop-down menu. So if I go back to Sort and Filter, let's select Custom Sort. Here, I can define a rule set for sorting our data. So I can sort by product first, from smallest to largest, and then we can add a level, and then sort by store in reverse alphabetical order, from Z to A. Let's click OK. And now we can see that product is sorted in ascending value, from smallest to largest, and within these product values, stores are sorted in descending order, from largest to smallest value. Now that we've sorted our data, we may also want to filter some of the values of each column. And to do this, I can select the filter option from the drop-down menu here. Let's add a filter. Now, each of the column headers have the drop-down icon within the column header. When I select the drop-down from the Store column header, I can filter to only return rows that have a value of A. So let's deselect all values and select A. We can see that the column is filtered, as the filter icon now appears in the column header. I can also select multiple values like A, C, and E. OK. To clear this column filter, I can either navigate back to the drop-down menu and reselect all items, or hit the Clear Filter from Store option from the drop-down menu. I can also navigate back to the Sort and Filter button and select Clear, and this will clear all the filters. Another option we have for filtering the data is a conditional filter on a column. Instead of clicking on multiple items, we can use the text or number filters from the column drop-down menu. From the volume column this time, let's select a number filter, and then let's select the greater than option. And we can select values where the volume is greater than 60, and select OK. Let's remove that new filter by clearing the filter to return to our entire dataset. Now we are more familiar with sorting and filtering our data, we can move on to other ways that we can analyze our data. We can make insights from our data really pop visually by using conditional formatting on our data. This feature builds on the concept of sorting our data. Previously, we sorted some columns in our dataset here, and we can do this visually by adding data bars to one of our columns. Let's select and highlight all the values from the volume column. Then we can navigate to the Conditional Formatting button, located on the Home tab of the ribbon under the Styles section here. From the drop-down menu, let's select Data Bars, and we'll pick one of these solid fill options. Now we can see, visually within the column, the relative high and low values based on the length of the bar in the background of the cell. Another conditional formatting option is adding color scales to data. Let's select the values of the price column this time and add color scales. From the Conditional Formatting button, Color Scales is just beneath Data Bars, and let's select the first option here. Now, values that are higher have a darker green color, and values that are lower have a darker red color. The background color of the other values fall on the gradient somewhere in between the two. At a glance, we can see a really low price, like here, as well as the higher priced items as well. We can add color scales to the next column, the cost column, as well. But this time, let's add the color scales in reverse. We want red for high values and green for low values. So I'll select the next option along. This is because a lower cost is better for us, and a higher cost is worse. The logic is opposite for the price column. And this is an important point with using conditional formatting. We have to ensure that we are using it to communicate the correct message. Let's clear the color scales from the cost column. We can do this by selecting the values and then navigating to Clear Rules and Clear Rules for selected cells from the drop-down menu. Just like with filtering the columns, we can also define our own conditional logic when using conditional formatting. Let's select the cost column again. This time, from the drop-down, let's select Highlight Cell Rules, and we'll select Greater Than. Now we can define the formatting rule we want to apply to these values. So let's highlight cost values that are greater than 20. So we'll highlight this value and type in 20. In the previous menu, we selected greater than as a type of conditional logic, but we could also select equals to, less than, or anything else that we would want to apply. Over here on the right-hand side, we have a few formatting options that we can apply to the values that meet the criteria that we define to the left. As I select the various options from the drop-down list, a preview appears in the sheet behind the menu. Let's go back and select this first option, light red fill with a dark red text, and we'll select OK. If we want to update any of the conditional formatting that we've built so far, we can go to Manage Rules. So from Conditional Formatting button, from the drop-down menu, the last option is Manage Rules. From this drop-down menu at the top, Show Formatting Rules for, let's select this worksheet. And now we can see the 3 rules we have defined: the rule set, the graded color scale, and the data bars. From this menu, we can directly add new rules, edit these existing rules, or delete conditional formatting rules. As we've seen, we have great flexibility to control and determine exactly what we want our conditional logic to be and how the formatting of this logic should appear. We have already seen conditional logic in action in the last few lessons, with filtering our data and by applying conditional formatting. Let's see how we can analyze our data by using functions that rely on conditional logic. Let's start by using the if function. You may have seen or heard of this function before. It is common in almost all programming languages. The if function has 3 parameters: a logical test, something to return if the logical test is true, and something to return if the logical test is false. In our data set here, we can use the if function to build some conditional logic around whether to buy or sell a particular category of item. In a new column, let's start in column H, we can type equals if. As we can see, the first parameter is to define a logical test. So let's do this by selecting the value in the category column for this row and see if it's equal to cat A. If it is, let's return the value of buy, and if not, we return the value of sell. And don't forget to put all of these text items in double quotes. I'll close the brackets and hit enter. Now I can take this formula and drag it down so that it populates for all rows of the data. And we can see for the first few rows, where category is equal to category A, the contents of this column say buy. But for the rest of the values, where they're cat B or cat C, we're instructed to sell. Currently, we only have 2 conditions in the if statement: if the condition test is true, or if it's false. However, we can add more conditions by creating a nested if statement. A nested if statement is when, instead of defining a value for false, we can define another if statement inside of the first one. Let's add a second conditional test, this time to see if the value is equal to cat B. So let's delete this cell for now, and let's type in if, and we'll do this again. If the category is equal to cat B, we want to sell. Otherwise, we want to hold. I need to close both sets of brackets because we have 2 if statements, so I'll accept this correction. And now let's drag this updated if statement down. And now we have some different instructions. The first few cells are buy, the next few are sell, and then we have hold. This method isn't too bad. We only have 1 nested if statement here. But we could keep adding more and more additional statements if our logic within our worksheet gets more complex. And the formula would become quite messy. It would be difficult to read, interpret, and maintain. So a function that we can use to replace nested if statements is the switch function. Here, we define an input, and then matching pairs of result and output. In our example, let's use the switch function here. The input expression is the value of the category column. Then we define matching pairs of result and output. So the result is the possible values of a column, like category A and category B. So let's type in cat A. And the matching response, if the value is category A, is buy. And then we can move on to our next option. If the value is category B, we want to return the value of cell. Otherwise, if the value of the category column is not cat A or cat B, we want the instruction to hold. And this becomes essentially the default value. Let's close the bracket and hit enter. And we can drag the formula down. We get the same output as our nested if statement, but when we click into the cell to see the formula, we can see that the syntax is much more clear. We see the single input and the matching pairs of values and results output. So far, we have defined the conditional logic based on a single value. What is the value of the category column? We did this in our nested if statement, as well as our switch statement. There were only a few potential options to answer this question: category A, B, or C. But we can also build conditional logic on numeric columns, where there are lots of potential values. In column K, let's create a new if statement. And this time, we will test to see if the value of the cost column is greater than 20. And this matches the logic of the conditional formatting that we defined earlier. If the cost is greater than 20, we can define it as large. Otherwise, it's a small cost. So let's do that here. If the cost column is greater than 20, we want to return large. Otherwise, we want to return small. Close the bracket and hit OK. And let's drag this down. If we wanted to add more complexity to the logic, we could once again create a nested if statement. This time, if the cost is less than 20, but greater than 5, we can return a medium cost. So let's update our if statement once again. We'll add another if the cost is greater than 5, it's a medium cost. Otherwise, a small cost. And we can drag this down once again. So once more, this method is not ideal. If we needed to add more thresholds, the nested if statement would get very messy, difficult to read and maintain. A function we can use to replace a nested if statement like this is the ifs function. The ifs function allows us to define multiple criteria and results. Let's start to build this formula in the next column here. Type in equal ifs this time, so IFS, and we can define our logical test. So if the cost is greater than 20, we want to return large. Then we need to define our next logical test. If cost is greater than 5, we want to return medium cost. One difference is that we also need to define a final test and value to return, rather than a leftover value if no tests are met. In this case, since small is returned for all values greater than 0, let's type in cost greater than 0 is equal to small. Our leftover value could be if cost is less than or equal to 0, we can return error because we don't expect any 0 or negative cost for any of our products. I could also use the value of true as the last test, a condition which all remaining values will meet, and then the ifs function will be satisfied. But let's explicitly define this last test here. I'll close the bracket and hit OK. Let's take this value and drag it down, and it matches this nested if statement. Once more though, this is a little bit easier to read and easier to maintain and audit as well. So we've seen how we can use the if function to define logic on both single values as well as conditional statements. If our scenarios are getting more complex, we can consider using the switch and the ifs function instead, as they provide a way to more easily define complex conditional logic. The sum product function returns the sum of the output of multiplying two corresponding ranges together. Let's multiply the volume and the price column together, and then sum up the values to return the total gross profit. We can do this calculation in its own column for each row of the data. Let's do that here in column H. We're going to multiply volume by price, and we can drag this formula down. Then, in a new cell underneath, we can sum all of the values of the rows by using the sum function. So in row 13, let's sum all of these values together. So this is our total gross profit. We can get the same result by using the sum product function. Underneath in row 15, I'm going to use sum product, and I can define a range of input for the volume, so all of the values of the volume column, and our second input will be all of the values of the price column. Let's close the bracket and hit enter, and we get the same result. For the sum product function to work, we need to ensure that our input ranges have the same number of values, so that our volume and our price column have the same number of rows. We can use the sum product function to do things other than return the sum of a product of ranges. We can also build a conditional sum product formula. For example, maybe we only want to return the gross profit for a certain input store, like store A, for example. So in column J, let's build our input. We'll have store, and underneath our store value, A. And we're going to reference this cell J14. Let's create an if statement in the next column over, in column K. And what we want to do is to return the product of volume and price if the value of the store column is equal to our input store here. Otherwise, we're going to return a blank. So we'll do equal if our store is equal to our input store, and I'm going to press F4 to anchor this reference to our input cell. If true, we want to multiply volume by price, and otherwise we want to return a blank, which we can denote with our double quotation marks. Let's close the bracket and hit enter, and drag this formula down. When we sum all of these values, make sure to include all 10 rows, we get our conditional sum product. For store A, this is the gross profit. As we update the store value, we'll see the output of our conditional logic will update too. So if I type in B, or C, or D, as our store changes, so does our logic of the if statements. Let's change that back to A. And we can update our sum product formula to return the same value following a similar logic. So let's type in sum product. We just need to add one additional parameter at the beginning. And this parameter will test whether the value of the store column for each row is equal to our input store. So in brackets, we can select our range of stores and test if it's equal to our input value. The next two parameters are the same, the range of our volume values and the range of our price values. I'll close the bracket. The last thing we need to do is add a double negative sign in front of this first parameter, and I'll explain why in just a moment. I'll hit OK. And we get the same value as the formula above. And as I update the input store value, our formula updates as well, and we return the same values as above. So our calculation works. But let's go back to see what's happening in this added parameter here, and exactly what it does. So first, we test to see if a store is equal to the input store. So let's do this in column M. We're testing if the store is equal to our input store. And we do this for each row in our data. And we see that we return true or false values. Then when we add 1 minus sign in front of the value, so minus this value, this converts true values into -1 and false values into 0. When we do math with Boolean values, or true and false values, true is equivalent to 1 and false is equivalent to 0. So when the value is true, we get -1. And when the value is false, we get 0. When we add the second minus sign, we are flipping the sign again. So -1s become 1, and 0s remain as 0. The double negative effectively converts the Boolean values of true and false into binary values of 1 and 0. The sum product function will then multiply these 1s and 0s by the price and the volume column. And it does that for each row in the data. And then we sum the values. The gross profit for rows where the condition did not match will essentially be multiplied by 0, so we only return values where the condition is true, as it is multiplied by 1 and therefore not impacted. If I change the store to B, or C, or D, we can see this logic is reflected in our calculation. Sum products and conditional sum products are a great way to analyze our data. They allow us to take ranges of data as inputs to quickly and efficiently analyze our data. In Excel, the let function allows us to define named variables within a formula. And there are two reasons we might want to do this. To improve the performance of our formula by eliminating redundant calculations, but maybe more importantly to make formulas easier to read and understand. Let's take a look at an example. We want to calculate the profitability of a single item as the volume multiplied by the price, and then we want to subtract the volume multiplied by the cost. In this column here, we're going to use an if statement. If the profitability is greater than 0, we want to return the value of the calculation. And if the profitability is less than or equal to 0, we want to return the message not profitable. So let's write out this formula. If we're going to say volume times price minus volume times cost is greater than 0, we want to return volume times price minus volume times cost. Otherwise, we want to return the message not profitable, and close the bracket. And we can drag this formula down to the bottom. So if I click back into the formula, notice that we are reusing the same calculation twice, as part of the logical test here, and as part of the output. This means that if we want to update this calculation, maybe to subtract a tax rate or a promotional sales value, we have to remember to update this in two different places. And this is not ideal. A best practice is to define logic only once, and then refer to this definition if we need to use it multiple times. And this is where the let function comes into play. We can use the let function to do just that in our example. Define a variable called profit, and then refer to this variable twice in the if statement. So let's do this in the next column over. We'll say equals let to bring up the let function, and we'll use 3 parameters for our example. We first need to name our variable, and we can call this profit. And note that we don't need to use quotation marks around the variable name here. Then, we need to define the calculation of the variable. We'll do volume times price minus volume times cost. And finally, we need to define a formula that uses the variable. we can use our if statement from before, but this time we'll replace the cell references with references to the profit variable. So we'll say if profit is greater than 0, we want to return the profit variable. Otherwise, we want to return the message not profitable. We can close the brackets there and hit enter. Let's drag this formula down and expand these two rows, and we get the same results for both. However, if we compare the syntax for this first example with just our if statement compared to the let statement, here it's much more clear what our calculation is. We define a variable and we get to use it multiple times within our formula. We've seen how we can use the let function in Excel to define variables within our formula to make them easier to read and understand. And we can apply a similar concept to different elements of our spreadsheet. We can use names, which can make formulas much easier to understand and maintain. And we can use names for things like a constant in a cell, a range of cells, or even a function and a table. So let's see what this looks like within this spreadsheet. I'm going to insert a few columns, and we're going to create a new column called growth price. But before we define the growth price column, we're going to define our growth rate. So let's define this down here, our growth rate, and it's going to be 10% or 0.1. We can define our growth rate formula as our price from our source data over here to the left, multiplied by 1 plus our growth rate. And I'm going to anchor the reference to this growth rate by hitting F4. Close the bracket. And now I can drag this down for all rows from our source data. So when I click on this formula, we can see that we're referencing cell E2, which is our price column, and then we have this 1 plus K14. And it isn't immediately obvious exactly what this is. We have to scan our sheet, go to K, go to row 14, to see that this is our growth rate. And what we can do instead is we can actually name this constant. So I can go to the name box, which is this area next to the formula bar. And let's make this a bit bigger. And once I'm selected onto cell K14, I can name this growth underscore rate. And now if I click back into our growth price column, I'm going to delete the reference to cell K14. And if I start typing in growth rate, we see that this is available to us in the IntelliSense now. And I'm going to hit OK and fill this down. So now when we look at the contents of the column, we see that we're multiplying cell E2 by 1 plus our growth rate. And it's immediately obvious exactly what this formula is doing. As well as an individual cell, we can also name a range of cells too. So let's take the example from our last lesson where we used the let function. And I'm going to take all of these values and let's name this profitability. And now down here, if I wanted to define and calculate our total profit, just using the sum function, I can run a sum on our profitability. Close the bracket, and we get our output there. And again, once I go back into that cell and look at the formula bar, we can see that we're summing our profitability. What's nice about using the name box, not only to name ranges or individual cells in our spreadsheet, but if I'm clicked anywhere in our spreadsheet, I can hit the drop down within the name box, and by hitting growth rate, for example, we navigate automatically to that cell. Or if I go to profitability, we highlight the range of cells that we've defined. So it makes navigating within our spreadsheet easier as well. Using the name box and names in a spreadsheet, we will see that we will use similar functionality with Excel tables later in the course. A final step with names is if we navigate to the Formulas tab on the ribbon, and the middle section is Defined Names. So I can click the Name Manager, and we can see the two names that we've defined, growth rate and profitability. If we want to delete or edit these, we have the ability to see everything that's contained within the sheet as well. And we're going to be using this in the next lesson. So just like we saw using the let function to create and name variables to make a formula easier, we can also use names, the name box, and the name manager in Excel to make different elements of our sheet easier to read and use within formulas as well. So far, we've looked at a few functions already. If, ifs, and switch for conditional logic, sum product for some mathematical operations and logical comparison, and the let function to define variables within a formula. Now, we can take a look at a way we can define our own functions and reuse them in Excel. Let's go back to our previous example here, where we were calculating the profit. We can define this calculation as the volume multiplied by the price before we subtract the volume multiplied by the cost. Let's build this calculation in column K. We'll do volume times price minus volume times cost. Hit enter, and let's drag this formula down. So within our worksheet, we are only doing this calculation once. So referring to a few cells to build the formula makes sense. But as we've already seen in our previous example, we might want to use this calculation again in other scenarios. We might want to build conditional logic off of it, like we did with our if statement here, or include it in multiple areas of the workbook. And there's no built-in Excel function that can take three inputs, volume, price, and cost, to run our calculation and return the output that we want of our profit. However, we can create this functionality using the lambda function. Lambda functions are found in other programming languages too. They allow us to define our own functions to use for analysis. Let's use the lambda function to define our profit calculation. In the next column here, we'll say equals lambda. So first, we need to define the input for our function. And in our case, we have three. We have volume, price, and cost. So let's type in these parameter names, volume, price, and cost. Then we need to define the calculation using these inputs. So we can rewrite our formula as volume times price minus volume times cost. And let's close our bracket. After we close the brackets, we should test our function. And we can do this by writing a new opening bracket and selecting three cells to be the input to our function. That corresponds to the order we've defined here, volume, price, and cost. So let's select volume, price, and cost. Close the brackets and hit enter. And we can see that we get the same value as the calculation beside it. So our lambda function is calculating correctly. And if we take this and drag it down to the row below, it calculates the correct value for this input too. However, we don't want the function in each cell to define the logic and then take input in a separate pair of brackets. We want to be able to use this logic as its own function. And we can do that by using the name manager. So let's copy this function, everything ahead of the test in the second pair of brackets, and I'm going to copy that. Then I'm going to navigate to the Formulas tab on the ribbon, and we have the Name Manager button in this Defined Name section. Here we can click New, and this is where we can save our lambda function. So let's name it calc profit, because we're calculating our profit. And here we can paste our function that we copied and hit OK. We can check the results in the previous pane here in our name manager pane. So we've defined calc profit, and it refers to this function that we've defined. It looks like our function was saved correctly, so let's close this pane. Now in the next cell down, we can type in equals calc profit, and this function is available for us to use. I can use the input of volume, price, and cost, close the bracket, and we can drag this function and formula down. And we see that it matches all of the values to the left. The lambda function is powerful and opens up lots of possibilities to analyze data in Excel efficiently by defining our own functions. In this chapter, we started our journey with analyzing data in Excel. Working through a few different examples, we saw some of the analysis features available to us in Excel. We looked at how we can interact with various buttons in the Data tab on the ribbon to analyze data. We saw how to create rules and make insights pop with conditional formatting. We also used Excel functions to write mathematical equations and conditional logic. And then, we built our own logic for our analysis using lambda functions as well as the let function as well. We are now ready to move on to the next chapter in the course, transforming our data in Excel.